Hey, good afternoon, everyone. We are ready to discuss critical areas in modern. So, this is SSD aware file system design and optimization by Ayup, Abdulwahab, Moallim, Muhamed, and Muhamed, Abdinor, Omar, and Usama. So, let's start it. The SSD revolution of performance is constraints, superior performance, and unique constraint and reduces lifespan. So the SSD of overload and the latency and mechanical reliability and reshaping modern storage. The utilize non-flash memory which has no moving parts, resulting the low intensity, meaning the data is accessed incredibly and fastly mechanical reliability. Unique constraint is this superior performance comes with unique constraint and non-flash memory technology, unlike all has disk drives that can otherwise data anywhere. So the two, I think, or three is the performing page-based writing, where the typical smallest unit for writing data this page, usually 4K, 4KB and 16KB. It has block eraser, meaning data and can only be erased much larger blocks. And finally, flash memory has limited endurance. Each memory cell can only tolerate finite number to erase cycle before it wears out. And release lifespan, as you can see here in efficient legacy file system leads to safer write application and degradation. This research analyzed conflict between legacy file system design and SSD architecture, exploring optimization technique for flash longevity and through output. The SSD internal understanding non-flash memory organization page, smallest unit for writing data for KB and 16KB. As you can see here, memory buffer hosts interface, CPU and LDPC, as you can see, encoder and the decoder controller. Block is collection of pages, smallest unit for eraser, balanced high-level structure, enabling parallel input and output. Erase before writing, constraint data can only be written to empty pages. Update require writing to new page and making the old as invalid, leading to costly garbage collection. And also the challenge of write ampliation, as you can see here, what is what ratio of physical writes to logical high accelerate and reduce SSD lifespan. Garbage collection copy invalid data from blocks between being erased to new location causes war and small miscellaneous writes. Small logical writes can trigger read modify writes. As you can see, cycle increases uh, cause of write application is primarily driven by two factors. As you can see, garbage collection, as we discussed it, when the data updated, the old data is marked invalid. SSD accumulation, many blocks containing a mixed valid life invalidate. Pages garbage collection is in the SSD process of cleaning up these vertically invalid blocks. To erase a block and invalid data from the block must be fast copied and to a new location. In this copy, invalid data that counts as a physical right is directly increase to the variation. And second is small miscellaneous right is the second major factor is efficient writing from file system non-batch area typical for KB and as you can see here 16 KB It must often trigger read, modify, write, cycle read entire page containing the target data modified a specific 1512 bytes in control page and then write in the entire modified page to a new location. This full page write is promoted by tiny change is highly efficient and significant increase. This is where the SSD aware file system design comes by aligning logical writes to the SSD physical page size. We can mitigate this issue and dramatically improve performance for longevity. Uh,
Hello everyone, and I am Muhammad Abdinor Omar, and I'm going to continue this part. It is we live in and garbage collection. So what is we live in and garbage collection? And this slide explains to core internal operation of SSD. We live in and garbage collection which work together to improve SSD reliability, performance, and lifespan. So, and we live in what we live in. We live in is a technique SSD to use to distribute writes efficiently across all memory blocks. And so there is two parts of and this part we live in. It is dynamic we live in and static we live in. And and the goal is to extend the SSD lifespan by preventing underwear. So let's see this part garbage collection. And garbage collection is used to free space inside the SSD. Because of SSD cannot override data directly, they must first erase entire blocks for writing a new data and garbage collection by this. And the goal is to maintain free space and keep the SSD running efficiently. Let's see this part. And limitation of traditional file system. This slide explains why older fast file system designed for mechanical hard drive and do not work efficiently with SSD technology. And there is some features like random write and exclusive. And so what is a random write efficiently? This part explains traditional file system assume of writing data is simple and impressive, which was true for HDDs. But SSD cannot override directly, and instead they must perform. And let's see the next part. Excessive metadata updates and journaling file system like Netflix and write metadata twice. And also we have a misline writes. This part explains the traditional file system use logical blocks size that do not match SSD page or block boundaries. And also this is our last slide. Let's explain SSD our design principle. This slide describes modern design techniques used to create file system and storage system that are optimized with especially for SSD behavior. And there is six features like TRM, discard support, and logic, structure layout, hot and cold data separation. What are they? Let's make them example. And the operating system tells the SSD which blocks are no longer needed. This allows the SSD to ensure them early. And, and write collecting, and its aggregates small writes into large input and output requires to maximize sexually and bandwidth. And also the last one is alignment with flash geometry. Ensure logical writes align with SSD page block boundaries to minimize RMW. Thank you.
So, Usamo Ali Mohamud. I will continue my part of this presentation, our presentation. Case studies, modern file systems. So F2FS Samsung Flash Friendly file system uses a log structured approach with optimized segments, cleaning and adaptive logging. Apple file system uses copy on write for metadata optimized for NVM and SSDs with space sharing principles. PTRFS Linux file system with copy on write for data metadata over advanced features, but can exhibit high WA if not planned. XT4 traditional FS adaptable with trim, SCADA, and mount options, but limited by this place update architecture. Future directions beyond current limits. ML driving real life in machine learning predicts hot data regions for proactive data placement and weird leveling. Solid SSD file system SNS exposes internal zone structure to the host, eliminating an FTL overhead for lower WE. Hybrid storage I/O orchestration combines high bandwidth SSDs with fast, low latency, non-volatile memory (NVM). And this is our last bit of our presentation. Hybrid FM SSD solution. The challenge even modern file systems struggling to fully utilize high bandwidth SSDs due to alignment costs and caching of data. Our principle maximize SSD performance by ensuring aligned iOS while NVM observes small unaligned residual iOS. Versioning proactively space user rights into aligning SSD iOS and unaligned NVM iOS. Triple data path utilize optimal multi-threaded direct I/O for SSD. Memory semantic for NVM and buffer for SSD reads. Efficiency demonstrates significant performance gains over existing SSD native and hybrid NVM NFD systems. I will stop here. This is the end of our presentation. Thank you for watching.